Observer design pattern is used when you need to separate the data from the views which depend on that data. So let's take a simple example so you understand better. So in an food or ordering app like Zomato, Swiggy, DoorDash, basically you can rate an order. After you have created an order and you have eaten your food, you can also rate an order. And that order rating affects the list of top restaurants which is shown on the UI when you open the app. So basically we have one on module which actually manages your orders, manages their ratings, and there is another module which actually shows the list of top restaurants based on their rating. So whenever any order gets rated here, it needs to be informed to the order module which is managing the list of top restaurants based on their rating. So here observer design pattern is used so that both these modules are loosely coupled. Now there can be more observers, more than one observers for same data. Let's take another use case from the food delivery system only. When you create an order, so there is a module which actually manages the creation of orders. It can be the same module which also manages the rating of orders. So you have a module which manages the creation of orders. Now there are multiple modules which need to observe this. The first one will be the user needs to be notified. So the module which notifies the users needs to be informed that okay, a new order has been created. Now send an email or WhatsApp or SMS or a mobile notification on the app itself. The another module is there which assigns delivery partner to a new order. So that module also needs to be notified whenever a new order is created. And again, you also need to notify the restaurants that okay, you have got a new order and now you need to start preparing food based on this order. So there is the third module which actually notifies the restaurants that needs to be informed. So you see there is a single module which manages the creation of orders, and that module has got three observers. So here also observer design pattern will be used so that uh, the subject, which is the module which creates the order, manages the creation of orders, is loosely coupled from its observers. That is the user notification module, and the module which assigns delivery partner, and the module which notifies the restaurant. Let's take a slightly different example from something other than a food delivery system. You may have worked as a front-end developer sometime and you may have used React. So in React, whenever you change the data structure inside JSX, the UI automatically changes. Or if you may have used Android Jetpack Compose, whenever you change the data structure, the UI automatically updates. This is called data binding. And again, there also observer pattern is getting used. So we have seen some of the examples as to why or when observer pattern is used. Now let's see the actual implementation. Now let's see how the observer pattern is actually implemented. This is just a skeleton implementation, and next section we will see the actual implementation in interview questions. Okay, so the first important part is subject. Subject is the class which implements this interface, will be actually the module which will have the data. Okay, so what it will do is whenever that data changes, it needs to notify all the observers. So it has these methods. The first one is add observer. So it will keep a list of observers so that it can notify them whenever changes happen to the data. There is the optional method remove observer. If you do not want to remove or need to remove observers, then you do not need to have this method. And then finally there is the notify all method. So whenever data change occurs, it will call this method to notify all the observers. So this will be our subject interface. Now second, there is going to be one or more observers. They all will implement this observer interface. Uh, this is the update method. This is a sample like information. Whenever data is updated, this info object is sent to all the observers. So for example, observer A is implementing the interface and gives it their custom implementation to the update method. Observer B does the same. Now there can be more observers. The benefit of this design is that let's say tomorrow both the subject and the observer are loosely coupled. So tomorrow if you want to add a new observer, so you can simply create a new class for that observer and have it implement the interface observer. Okay, and simply call the add observer method inside the subject, you do not need to change any single line of code inside the subject, which reduces the complexity of extending the code. So this is major benefit of it. And also the observers, it's on them that what they want to do with the update. They may choose to ignore it or choose to process it. That's their decision. So let's see some actual examples from the interview questions. Now let's see how observer design pattern is used in actual interview questions. So let's take the example of this design a food delivery system like Zomato, Swiggy, Uber. I have already opened the question. So here you have to actually, you can, in a food delivery system, you can basically order food. You can also rate order, and there are two methods to display top restaurants based on their rating. There is slight difference between them, but for our case, let's assume we have got two methods which display list of top restaurants based on their rating. And then we have the method rate order. So like we were discussing just now, the module which is rating the order is the subject, and the modules which are showing these lists will be our observer. So let's see how we have implemented. So our interface, we have named it rate order observer, and it has an update method, and our subject will have method to add observer and notify all observers. There is no method to remove observers because we do not need it. So let's see the observers first. These two classes, most rated restaurants and most rated restaurant by food, these two classes return the list of top restaurants. So they are the observers, and they maintain their internal list of restaurants in their custom data structures. So these two classes needs to be informed every time a new order is rated, so that they can update their internal data structures. So our class orders manager will be our rating order subject or subject. What it does is it keeps list of all the observers in an array list, and it has the methods which are required. So we have the add observer method to add the observer and notify all of the observers. Simply go through all the observers in the array list and call the update method on each of them, because they all follow the same interface. And when the order is rated, simply call notify all to notify all observers. So this is how a basic implementation is done in case of uh, uh, a food item, a food delivery system. So let's suppose tomorrow we have to add a new observer. Let's suppose we want to list top restaurants which have got the highest number of 5-star ratings. So again, here also we'll simply create a new class here, just below these classes, highest or most 5 rated restaurants. Okay, and that class we will add to this observers list using this method add observer, and whenever a new rating comes, uh, it will be notified through this notify all method. Now that class will ignore all other ratings except the 5-star rating, so it depends on that class, and we do not have to make any single line code change in the orders manager. So this is actually, you see how it is good for extending code. Now let's see a slightly different example where an observer pattern is used along with strategy design pattern. So let's take the case of a customer issue resolution system. So in a customer support system, what happens? Customers raise multiple issues, and those issues are assigned to different agents who solve them. So here in the assign agent method, we have been applying 3 different strategies to assign agents. That can be depend on the number of issues open by the agent, or how many issues of that type agent has already solved. Basically different factors. The key thing to understand here is there are 3 different algorithms for assigning agents. So these 3 classes are the ones which have implemented all of these 3 strategies. Okay, so these 3 classes also have their own data structure, and we need those. So every time a new agent is assigned an issue, then all these 3 classes need to be informed about that, so that they can update their internal data structures and return or assign new agents to the issues correctly. So we have used observer design pattern here. The name of the interface is issue observer. It has updated method. Uh, then we have the issue subject, which has the attach and notify all method. So these three classes will be our observer in this case, because they have their custom list of not the list, they have their data, or list of all agents, and then they use that data to assign agents to different issues. For example, this lowest issue open selector, it has all the agents in a map, and our issue subject will be class issue manager, because it is taking care of all the issues when whether a issue is getting created, resolved, or assigned. It has the attach and notify all methods. It stores all the three observer classes in this array list of issue observer. And this code is pretty simple. We just saw it. It is similar to the one that we saw in the previous example. And whenever an issue is assigned to a new agent or any agent, it calls notify all to notify all the three algorithm classes. So in this case, we have used observer pattern with strategy design pattern, so that every different algorithm is informed about the data changes in the core data structure, that is an issue which is getting assigned to the any agent. So if you want to take away just one thing from here today, just remember that observer pattern is used when you want to have loose coupling between data and the views which depend on that data. So this is all about observer design pattern. Now I have created a 7-day plan for preparing for your low level design interviews. You can access it at codegym.com/roadmap. So generally you have very less time to prepare for LLD interviews, because the interviews are either in this week or upcoming week. So you won't have more than 7 to 10 days to prepare. So I created this concise plan to answer all the questions which candidates have, because there are ton of content on the internet and on YouTube. So people have questions like which topics to prepare first, because time is of essence, and where to practice. So it has got everything. It has got short videos on every day that you can watch, and there are daily practice questions you can which you can code and run it on CodeGym editor, and see that it passes all the test cases. So basically it's the complete thing which you get. So give it a try, codegym.com/roadmap. It will help you prepare for your LLD interviews pretty efficiently. Thanks for watching till here. Best of luck for your interviews. Bye.